Hello everybody. In this video we're going to be taking a look at combining like terms. Simplifying expressions would be a synonym for this. So if we're given an expression or a pair of expressions like 8n plus 5 and 13 plus 6n. Okay, and we're told to simplify the result. Combining like terms, we're thinking about literally what it sounds like, combining the things that can be combined. So for example, starting with the variable expression, we have 8 variable expressions. We have 8n and 6n. Those are like terms. They're both in terms of n. The coefficients are different, but obviously that doesn't impact the fact that they're like. They're both n's. We have 8 of them and 6 of them. So altogether, we would have 14 n's. Kind of like grouping things that, or counting things that can be grouped together appropriately. And then just plain old number-wise, constant, if we want to refer to them as that. We have a 5 and a 13, which would, again, counting, give us 5 and 13 would give us 18, for a grand total of 14n plus 18. Okay, like terms, we're combining variables. There's a little exception with that. We're going to take a look at one more example when exponents are involved, but variables can be grouped together, and same thing with constants here in this first example. So moving on to a second example, we're going to see something like this. Say we have 3a squared plus 7 plus 8a plus a squared minus 3a and minus 5. Okay, so this one's written out a little bit more horizontally. There's more things going on. So very important what we pair up, or what we, not necessarily pair, but what we group together. Also important, we see multiple representations of a. We have an a squared and also a regular a term. Those are treated differently. Okay, for example, I like to start with, the very first expression I see, 3a squared. The only like term for 3a squared would be the a squared. Okay, there's a coefficient of 1. You can write that in if you like for the a squared. So altogether I have 4 a squareds. The rule with like terms, they have to have the same variable and the same exponent. So if different exponents are involved, you can kind of group them all together. Oh, they all have an a, they're all like terms. We cannot do that. Next, I have a plus 8a. Notice I'm taking the sign into consideration with all of these. I have an 8a and a minusing, or taking away, I should say, 3a. So 8a minus 3a, 8a minus 3a would give me a grand total of 5a. And last but not least, my constants, my regular plain old numbers. These are the easiest to pair up. No variables, no exponents to consider. But I do have a little sign there I want to be careful with. 7 minus 5 would give me a grand total of positive 2. So taking a look at your final answer here, you would not, some people take this one step further and they do some variation of this. Maybe 9a cubed or something like that incorrectly. Okay, obviously we can't do that. A squared and a are two different things. We can't count them as the same term. So with variables, they have to have the same exponent, and obviously the same base, the same variable. That would be perfectly simplified. We can't do anything further with this. We get a trinomial. Nothing more we can do there. Okay, this is combining like terms. I didn't mention this, but obviously making different shapes, underlining. You don't have to go crazy and pull out 20 different colored markers, but all of these strategies do help kind of visually see what, being able to see what you're pairing up together. Okay, thank you guys.